In October of 1924, a chemist sat down at a table in New York in front of reporters and washed his hands in a bowl of a clear, oily liquid. Then he leaned over the bowl, closed his eyes, and inhaled the vapor for a full 60 seconds. He looked up at the camera as he was smiling. The liquid in that bowl was tetraethyl lead, and he knew better than anyone alive exactly what it did to the human body. He knew because a few months earlier it had almost killed him. His name was Thomas Migley Jr., and by the time he died, he would be responsible for two of the largest environmental catastrophes in the history of the planet. Not by accident, not by ignorance. He knew. His bosses knew. His colleagues knew. And they built one of the most profitable industries of the 20th century on top of that knowledge, and then buried it under a marketing campaign so effective that most of us are still living inside its consequences. You'll hear a lot of stories about villains in white lab coats. This isn't one of those. This is a story about a genuinely charming, endlessly clever man who won every major chemistry award America could give him, a man his colleagues loved, a man who at his funeral was described as one of the most brilliant minds of his generation. And that's the part that should unsettle you. Because the poison didn't come from someone twirling a mustache in a laboratory. It came from a smart, likable engineer who solved a very small engineering problem, and in doing so, quietly rearranged the chemistry of the entire atmosphere. To understand how one person managed that, you have to go back to a workshop in Dayton, Ohio, in the early 1920s. Cars were the future, everyone could see that. Ford's assembly lines were pouring Model Ts onto American roads at a pace no one had ever seen. But there was a problem. When engines pushed for more power, they made a sound, a rattling metallic pinging, like something loose was bouncing around inside the block. Engineers called it knock. And knock wasn't just annoying. Push it too far, and the engine tore itself apart. At General Motors, a chemist named Charles Kettering assigned the problem to his young protege. That was Migley. And for 6 years, Migley and his team ran through thousands of compounds looking for one that could stop the knock. They tried melted butter. They tried camphor. They tried, at one point, ethyl alcohol, which worked beautifully, was renewable, and could have been distilled from crops. But ethyl alcohol had one commercial defect. You couldn't patent it. Anyone could make it. There was no fortune in it. Then, on December 9th, 1921, Migley found something better, a compound of lead. Add a tiny amount to gasoline, and the knock disappeared. Engines ran quieter, cooler, more powerful. It was, in industrial terms, a miracle. But there was one small problem. Everyone in Migley's field already knew that lead was one of the oldest known poisons on Earth. The ancient Romans had written about it. Benjamin Franklin had written about it. In 1900, a British medical journal had published a paper titled Insanity in Lead Workers, describing what happened to the human brain after prolonged exposure. Migley was a chemist. He knew all of this. When he wrote to his supervisor about the discovery, he even used the word poison in the letter. So the question wasn't whether tetraethyl lead was dangerous. The question was whether they could sell it anyway. The answer from General Motors, from Standard Oil, from DuPont was yes. They formed a joint venture called the Ethyl Gasoline Corporation. Not the Leaded Gasoline Corporation. Not Lead Fuel Incorporated. Ethyl. The word lead was scrubbed from every label, every advertisement, every gas pump. If you pulled up to a station in 1924, you asked the attendant for ethyl. The green pump was ethyl. The signs were ethyl. The additive was, in every public document, just ethyl. This was not an accident. It was an internal decision made in writing to hide the substance from the customers, who would breathe its exhaust for the next 60 years. And then, almost immediately, the workers making it began to die. There was a refinery in Bayway, New Jersey, run by Standard Oil, where the tetraethyl lead was produced. The men who worked there didn't call it the ethyl building. They called it the loony gas building. In the fall of 1924, workers there started coming apart. Not all at once, one at a time. They'd start with a tremor, then confusion, then hallucinations, then paranoia, then rage. A man who had been perfectly ordinary at breakfast would be strapped into a straitjacket by dinner, screaming at things no one else could see. By the time the state of New Jersey shut the plant down, at least 5 workers were dead. Somewhere between 30 and 35 were hospitalized. One man, Joseph Leslie, was reported dead to his family, but he wasn't. He'd been quietly moved to a psychiatric institution where he would remain, catatonic, for the next 40 years of his life. His wife knew. His son knew. The public did not. Similar things were happening at a DuPont plant, where another 10 men died. At GM's own facility in Dayton, 2 more died, and 40 were hospitalized. The papers picked it up. Public health experts sounded alarms. A woman named Alice Hamilton, a physician at Harvard and the first female faculty member of that university, called it, in a phrase that has aged remarkably well, a malicious and creeping poison. She said, at a public hearing in Washington, that there were thousands of things better than lead to put into gasoline. She was right, there were, but none of them made anyone as rich. So Standard Oil called a press conference, and Midgley, the man who a year earlier had been forced to leave his own laboratory because his hands had started shaking and he could no longer stand the smell of the compound he'd invented, stood in front of reporters, poured tetraethyl lead into a bowl, and washed his hands in it. He told the room he could do this every day of his life without any harm at all. What he did not tell the room was that he had spent the previous winter in Florida on medical orders, trying to recover from lead poisoning so severe it had almost ended his career. The demonstration worked. The story died down. The federal inquiry in 1926 concluded that leaded gasoline in dilute form posed no immediate danger to the general public. That conclusion would stand unchallenged for the next 40 years. Within a decade, 90% of gasoline sold in America contained lead. And here is where the story starts to get quietly enormous. Because leaded gasoline didn't stay at the pump. It didn't stay in the engine. Every gallon burned released microscopic particles of lead into the exhaust, and every exhaust pipe in America was pumping those particles into the air you breathed. It settled on the sidewalks children played on. It settled into the soil where vegetables grew. It rose into the atmosphere and drifted on the wind to places no car had ever been. We know this because of a second man. And to be fair to the truth, you can't understand what Midgley did without understanding what it took, a full generation later, to prove it. His name was Clair Patterson. He was a geochemist at Caltech. And in the 1950s, he wasn't trying to expose anything. He was trying, of all things, to measure the age of the Earth. To do that, he needed to analyze the lead isotopes inside very old rocks. And every time he ran the experiment, his samples were contaminated. There was lead everywhere, on his equipment, on the floors, in the water, in the dust that fell from the ceiling. He built one of the world's first clean rooms just to escape it, and even then, the contamination followed him. At some point, staring at his data, Patterson realized what he was actually looking at. It wasn't lab error, it was the world. The lead was everywhere because the air itself had been changed. So he went to Greenland. He drilled into the ice and pulled out cores containing layers of atmosphere frozen in place, one thin band for every year going back centuries. What he found in that ice when he read it like a book was the exact moment the industrial world had been poisoned. In every layer of snow that had fallen before 1923, lead levels were low, normal, consistent with what nature produces on its own. And then, in the layer of snow that had fallen in 1923, the year Ethel went on sale, the numbers began to climb, and climb, and climb. By the 1960s, atmospheric lead in the polar ice was hundreds of times higher than it had been before Midgley's discovery. The lead hadn't stayed at the gas station. It had gone everywhere. It had traveled to the North Pole. It had settled into the bones of every human being alive. When Patterson published, the industry came for him. He was cut off from research funding. He was disinvited from panels. His contracts were quietly canceled. He was called eccentric, obsessive, unreliable, and it took another 20 years of scientific fighting, court cases, and regulatory battles before the United States finally began to phase out leaded gasoline in the 1970s. The last drop was sold in America in 1996. The last country on Earth to stop selling it was Algeria in 2021. That's the full arc, from invention to global ban, almost exactly 100 years. And in the middle of that century, in every one of those decades, tetraethylate was pouring out of tailpipes into the lungs of children. Which brings us to the number that, honestly, is the hardest part of this story to sit with. A study published in the Lancet Planetary Health in 2023, funded by the World Bank, tried to estimate the current annual toll of lead exposure worldwide. They didn't just count acute poisonings, they counted the downstream cardiovascular deaths because lead damages the heart. They counted the cognitive damage in children under 5 because lead damages the developing brain. And the numbers they came back with were staggering. More than 5 million deaths a year globally tied to lead exposure. 765 million IQ points lost every year from children under the age of 5. For context, a separate American study in the Proceedings of the National Academy of Sciences estimated that more than half of the United States population living today has been measurably affected. Americans born in the 1960s and 70s, when leaded gasoline emissions peaked, lost an average of somewhere between 6 and 7 IQ points each. Not all of it recoverable, not any of it optional. It was in the air they breathed on the walk home from school, and the man responsible was not finished. Because in 1930, 6 years after the Bayway workers went insane, Thomas Midgley Jr. invented something else. General Motors had asked him to find a safer refrigerant. The refrigerators of the 1920s used gases that were flammable or toxic, ammonia, sulfur dioxide, and every so often, one of them would leak in someone's kitchen and kill a family in their sleep. It was a real problem. Midgley solved it in a matter of weeks. He created a stable, non-toxic, non-flammable gas. He called it Freon. It was a chlorofluorocarbon, a CFC. At a chemistry conference, to demonstrate its safety, he inhaled a lungful of Freon and used it to blow out a candle. The audience applauded. The gas went into millions of refrigerators, then into millions of air conditioners, then into every aerosol can in the world. For half a century, the industry celebrated it as the safest chemical ever invented. Then, in 1974, 2 chemists at the University of California realized what Freon actually did when it reached the upper atmosphere. It broke apart. It released chlorine. And the chlorine, over years, ate the ozone layer, the thin band of gas that protects the surface of the Earth from ultraviolet radiation. By the mid-1980s, satellites over Antarctica were photographing a hole in the sky the size of a continent. Skin cancer rates rose, ecosystems shifted, and every molecule of the gas causing it could be traced back to the same man, working in the same laboratory, for the same company. The environmental historian J.R. McNeil put it in one line that has become famous in his field. Thomas Midgley Jr., he wrote, had more impact on the atmosphere than any other single organism in Earth's history. Not any other single person, any other single organism, including all the ones that ever lived. And the machinery that produced him, the corporate labs, the marketing departments, the deliberate branding of ethyl, the press conference stunts, the funded studies, the captured regulators, is not a museum exhibit. It is a template. The same playbook was used later for tobacco, for asbestos, for a dozen chemicals you have never heard of, because the fights over those never made it out of the trade press. The Midgley story is not a story about one man. It's a story about how easily a system can wrap a poison in a friendly name and sell it to you for a century. Which is why the next time you hear a new product described with a suspiciously warm brand name, an industry-funded safety study, and a spokesman insisting that critics are eccentric, pause. Pause and ask, for that specific product, in that specific year, what Alice Hamilton would have said, because she said it about lead in 1925, in a room full of oil executives, and she was completely right. And it took the world 60 years to catch up. That's the perspective. That's what you can carry out of this. Not paranoia, not doom. Just a slightly sharper eye for the difference between what a company calls a product and what a product actually is. Every substance has a real name. Every real name has a real history. And the shorter and friendlier the brand, sometimes the longer and harder the story underneath. Migley didn't live to see any of it. He caught polio in 1940 and was left partly paralyzed. He built himself a system of ropes and pulleys so he could roll himself in and out of bed unassisted. On the morning of November 2nd, 1944, he was found strangled in that harness. The coroner ruled it a suicide. He was 55 years old. 2 years earlier, he had received the Priestly Medal, the highest honor the American Chemical Society could bestow. In his acceptance speech, he described himself as a lucky man. The compounds he had invented, he said, were among the great gifts of chemistry to civilization. He was, by every account, a warm and generous person. His friends adored him. His colleagues mourned him. And that, more than anything else in the story, is the thing that should stay with you. Because the man who put lead in your grandparents' bloodstream and holes in the sky above your head was not a monster. He was a chemist with a family, and a mortgage, and a chair on the board of the company selling the poison. He knew. His employers knew. The doctors warning them knew. And they built the industry anyway. Which brings us back to the bowl. October 1924. A room full of reporters, a smiling man dipping his hands into a clear, oily liquid, breathing in the fumes, telling the world it was completely safe. He was not lying by mistake. He was lying because he had recovered from lead poisoning less than a year before. He knew, in every nerve ending in his hands, exactly what he was inhaling. Now you know it too, and that's not a small thing to know, because for 100 years, the whole point of that press conference was that you wouldn't.